In light of everything, we got a gander at a couple of shocking pictures as the Webb peers back around the start of all that the James Webb Space Telescope (JWST) has uncovered. A divulgence that challenges the external layer of our cognizance. This new disclosure has prompted the premium of stargazers and scientists and recommends a perhaps immense event that could change the universe to the extent that we may be concerned. The finding is fundamental for the point that it raises issues about the legitimization for our vast presence. Might this openness sometime or another lead to the furthest reaches of all we eventually know is the universe, close to the certified edge of an extraordinary event past our ongoing getting it? Oblige us as we examine the latest exposure of the James Webb Telescope and how it could shape the universe. At the point when we analyze the universe's edge, we start with the discernible universe. It looks like seeing through a window into the district past the discernible universe. The observable universe consolidates all that could be presently seen, estimated, and investigated with our telescopes and space missions. It is a grouping of stars, universes, and wonderful bodies that are indisputable to us. Nonetheless, the undeniable universe is fundamentally a piece of the entire universe, a piece of a gigantic, epic pie that individuals can survey and see. However, the general size and kind of the universe stay a secret. The width of the conspicuous universe is around 93 billion light-years. This figure is the outcome of different factors, including the distance that light can go in 1 Earth year, 9.46 trillion kilometers, or 5.88 trillion miles. A light year is the distance gone by light, the fastest thing known to man, in 1 year. The evaluated age of the universe since the huge explosion is 13.8 billion years. This suggests that light released by objects in space that we can see has been going toward Earth for practically 13.8 billion years. That recommends that the obvious universe is 13.8 billion light-years toward every way from Earth and 27.6 billion light-years in width. Nonetheless, Hubble's insights exhibit that space has been reaching out since the huge explosion. Thus, the clear universe has been creating. Assessments of this expansion show that flights that created light 13.8 quite a while back from a distance of 13.8 billion light-years are presently through farther away from Earth, around 46 billion light-years away. This shows that the discernible universe fills more than 46 billion light-years toward each way from Earth and has a breadth of around 93 billion light-years. So, when we say the perceptible universe's broadness is 93 billion light-years, we're examining a staggering reach from around 13.8 a long time back in a phenomenally clearing impact. This impact began what we as of now suggest as the consistent expansion. Since that pressing second, the universe has not only been expanding, however, has moreover been accelerating. Confusing powers like the mysterious, dull energy seem, by all accounts, to be driving the speed increment, extending the universe's limits at any point further. As issue outlined under the draw of gravity as the universe broadened, this gravitational fascination pushed particles together, achieving the improvement of bewildering plans like stars, universes, and at last planets, like our own dear Earth. Given the universe's reliable turn of events, the obvious universe connects by another light-year each Earth year. All the while, light from farther particles keeps on showing up at Earth. Inquisitively, this suggests that we are seeing legitimately a more prominent measure of the universe over the long run. While we can continually not notice the entire universe from Earth, the field of insight is tenaciously creating. Propels in development get and analyze electromagnetic radiation past the obvious reach, allowing us to find and view faraway individual frameworks, packs, and superclusters in the recognizable universe. Explicit telescopes like radio telescopes, X-beam telescopes, bright telescopes, infrared telescopes, and others have been significant in such way. The famous Hubble Space Telescope and James Webb Space Telescope have engaged the impression of the essential stars and frameworks that emerged in the detectable universe, making these wonders more available to people in general. Despite its immensity, the universe is strikingly unfilled. Whether or not we diminished our entire planetary gathering to the size of a quarter, the nearest star would regardless connect with 2 soccer fields away. This colossal void loosens up inside our own smoothway world, which is one of billions in the observable universe, outfitting us with a sensation of its massive degree. You may be inquiring as to why we can't just see everything there of psyche. There are a couple of explanations for this breaking point. No matter how light is the fastest article known to man, it actually expects time to go through space. This suggests that when we look at faraway items, we are fundamentally thinking back in time. The farther away a thing is, the more its light has taken to reach us. It looks like looking through a giant time machine, disentangling the verifiable scenery of our universe as we witness the universe's millions, on the off chance that not billions, of light years away. Notwithstanding, there is another part significantly affecting everything. The universe is expanding. Think about the external layer of an expanded inflatable covered in spots. The bits move separated from each other as the inflatable creates. The universe keeps a near rule. Universes float away as the surface of room expands. The light sent by a wide margin off objects goes through a change known as redshift. Because of this turn of events, light frequencies are reached out, with objects moving away moving to longer frequencies, which are for the most part obvious as a ruddy assortment. A few heavenly bodies ultimately pass past a basic distance, known as the infinite skyline, where their light is unnecessarily far away to reach us in view of the universe's broadening nature. Given these two essential components, the light's entry through time and the advancement of the universe, it's not stunning that we haven't seen the whole universe yet. Without a doubt, even with the most moderate telescopes and innovation, our vision stays obliged by the vital characteristics of the universe. We ought to dig a pinch more into these thoughts. The universe's size is amazing. Specialists use assessments like light years to address the distance that light goes in a year, around 5.88 trillion miles or 9.46 trillion kilometers. Our universe, the smooth way, is right around 100,000 light-years across. Indeed, even inside our world, the closest star to our Sun, Proxima Centauri, is around 4.2 light-years away. At the point when we examine space, we can see systems billions of light-years away. This suggests that the light we see from those systems started its excursion billions of years prior, giving us a short investigate the universe's initial history. The mystery of the universe's edge and the mission to appreciate its possible cutoff points or limits positively stand apart to numerous people from various fields. While definitive reactions keep on getting away from us, three basic hypotheses have emerged, each offering an uncommon point of view on the immensity of room. The primary speculation recommends that the universe is vast, with no authoritative end. This thought lines up with the cosmological guideline, which expresses that the universe is isotropic. Its consistency and appearance are the identical from every vantage point. Expecting this speculation is legitimate, it recommends that the universe has no limitations and can extend immeasurably. The ensuing speculation offers an elective view, battling that while the universe might be restricted, it missed the mark on an evident edge. Rather, it is contrasted with a huge, bended space like a globe. For this present circumstance, on the off chance that one in some way figured out how to go toward any way perpetually, they would eventually return to their beginning stage, similarly as circumnavigating the Earth. The third speculation, the multiverse hypothesis, presents the enthralling idea that our universe is only one among many. Imagine a massive number of universes, each with its own game plan of genuine guidelines, constants, and properties. These universes might be absolutely novel and work freely of each other, or they may be interconnected through complex associations, outlining a monstrous and multi-layered multiverse. Analyzing these theories creates both consistent and philosophical premium. The possibility of an unlimited universe challenges our considerations about space and our impression of its boundlessness. Then again, a restricted universe without an edge difficulties our thoughts of endpoints and cutoff points, recommending the possibility rehashing plans inside the surface of room. The multiverse hypothesis, with its equivalent universes, offers a rich scene for investigation, proposing the presence of spaces inconceivably not exactly equivalent to our own. If certified, it would suggest that assortments in genuine guidelines and key constants could provoke totally different kinds of presence, opening up a huge domain of expected results past our ongoing comprehension. Nonetheless, these considerations stay speculative and unobtrusive. Investigating the universe's edge presents enormous difficulties. It is difficult to totally show or discredit these hypotheses because of the tremendousness of room and the restrictions of our ongoing observational apparatuses and innovation. The excursion to reveal the universe's edge has been a spellbinding outing, affluent in hypotheses and reflections. However, one noteworthy instrument, the James Webb Space Telescope, JWST, stands apart as a promising sign, uncovering experiences into the secrets that cover the universe's beginnings. This amazing instrument can possibly reveal our universe's mysterious history, permitting us to acquire information a long ways past what was recently envisioned. The JWST is a mechanical marvel, explicitly intended to notice the universe with unmatched exactness. Its pivotal components engage us to investigate the universe's beginnings. The JWST has found gigantic universes going back between 500 million and 700 million years after the huge explosion. As per late examination distributed in Nature, these old cosmic systems challenge assumptions, with sizes altogether bigger than expected for their age. These stunning exposures cast vulnerability on spread-out theories.